Everyone, in this video we are going to be looking at friction, and all that has to do with friction. Here we see that friction is the resistance to motion of one object moving relative to another. So when an object is moving relative to another, friction is experienced. Let me quickly draw a diagram here. Let's say we have an object maybe moved by a force on a rough surface. You should know that friction always happens on a rough surface. Okay, so when a force is pulling this object, there will be an opposing force acting the other way around. That opposing force is called friction, which is due to the resistance in the motion as they are in contact to one another. Okay, so there are two types of friction. We have static or limiting friction. Now actually there is a little very slight difference between static and limiting friction, but in this case we'll treat them as one. Then we have dynamic or kinetic friction. Now, static friction is the friction of a body when it is about to move. So when a body is about to move, that friction is static friction, and actually is usually the highest friction that exists in between two surfaces. Then the second one is dynamic friction. Dynamic friction is a friction when the body is already in motion. When the body is already in motion, the friction it experiences is dynamic friction. Now, but please, we should know that static friction is usually greater than dynamic friction. Maybe I should write that this is frictional force. Static Fs is always greater than the dynamic friction, or Fk. Remember, dynamic friction is also called kinetic friction. Okay. Now, what is the formula for friction? Friction is F equal to mu R. The mu here is coefficient of friction. The R here is normal reaction. Now, the mu, coefficient of friction. Okay, so the mu there is the coefficient of friction. The R is the normal reaction. Now, this coefficient of friction can be coefficient of static friction, or it can be coefficient of kinetic friction, any of them. Okay, in the course of the video, we are going to see what normal reaction is. For plane surfaces, the normal reaction is mg, that's mass times acceleration due to gravity. But if the surface is an inclined surface, your normal reaction is mg cos theta. Okay, so you see that normal reaction is a force that is exerted by a surface on an object in contact with it, which prevents the object from passing through the surface. Okay, so the force is perpendicular to the surface and is the only force that the surface exerts on the object in the absence of frictional force. Okay, let me put this straight. Now, if you have, let's say, a plane surface and an object on a plane surface, the object exerts a force on the plane surface, which is what we call the weight, W, and we know that weight is equal to mg. But the plane surface also exerts a force on the object, which moves upward. So that force that prevents the object from sinking, that is what we call the normal reaction. And for a plane surface, if you notice, according to equilibrium, your R is definitely equal to W, which is equal to mg. Okay? But for an inclined surface, it's the other way around, which we're going to see further. Okay, so an object resting on a plane surface is acted upon by two forces. So like we can see in the diagram, we have R, which is the normal reaction, then the weight, which acts downward. The weight is the force the object exerts on the surface, but R is the force the surface exerts on the object. Just like when you sit on a table, you're exerting a force on the table, but the table is also exerting a force on you. That's why you feel pain when you stand up after sitting. Okay, so that leads us to laws of solid friction. Okay, now the first law is that the friction of a moving object is proportional and perpendicular to the normal force. So friction is always proportional and perpendicular to the normal force. We are going to see that that's why. Okay, let me write that somewhere. That's why we say that F is proportional to R, meaning that F is equal to mu R. So the proportionality constant is the coefficient of friction. Okay, we see that the friction experienced by the object is dependent on the nature of the surface it is in contact with. So friction depends on the nature of surface it is in contact with. Friction is independent of the area of contact as long as there's an area of contact. It does not depend on area of contact. The next is that when an object is about to move, the frictional force is equal to the applied force. Please note this. When an object is about to move, the frictional force is equal to... Okay, so the next is that the coefficient of static friction is greater than the coefficient of kinetic friction. I think I've told you that before now. And here the kinetic friction is independent of velocity. The kinetic friction is independent of velocity. Okay, so we see a diagram here. On the left side we have the static friction. On the right side we have the dynamic friction. Now remember that the resultant force acting on a body is equal to mass times acceleration. And in both diagrams you can see that the resultant force, since the forces are moving in opposite direction, resultant force is F minus frictional force must be equal to MA, which is exactly what you have here. Now, but under static friction, static means that the object is not moving, it has not started accelerating. So it means that the acceleration here is 0. So you are going to have F minus F equal to 0. 0 times M is 0. That means your F now is equal to frictional force. So that's why we have this formula for static friction. Okay? So for static friction, when an object is about to move, the frictional force is equal to the applied force. But when an object is already moving, then the difference in their force, that's F minus F, is equal to mass times acceleration. Okay? Now let's see a question here. We are given that an object of mass 80 kg is pulled on a horizontal rough ground by a force of 500 newtons. Find the coefficient of static friction. That means it is about to move. Okay? So the coefficient of static friction, we say that F is equal to F. Now the force here is 500 newtons. Your frictional force is not given, but we know that frictional force is equal to mu R. Or we can just say mu mg, since R is mg. So we have that 500 newtons is equal to mu times the m is 80. The acceleration due to gravity, we're asked to use 10. Okay, so 500 is equal to 800 mu. Okay, so now to get mu now will be 500 over 800, which is going to give us 0. Sorry, let me check that quickly. 500 divided by 800. And we got 0.625. So 0.625 is the answer, which is D. That's the closest answer to that. Okay, so look at another question. A force of 10 newtons drags a mass 10 kg on a horizontal table with an acceleration of 0.2 meter per second square. If the acceleration due to gravity is 10 meter per second square, that's a mistake. The coefficient of friction between the moving mass and the table is, Now in this case now the mass is moving. So what formula am I going to apply here? That is F minus F equal to ma. You see that? So when it is static, when it's about to move, F is equal to F. But when it is static, you have this. So we can say F minus mu mg is equal to ma, because frictional force is mu mg. Okay, so the force F here from the question is 10. The coefficient of friction is what we are looking for. Mg, mass times acceleration due to gravity. The mass is 10. Acceleration due to gravity is also 10. We are using 10. Equal to the mass is 10. Then the acceleration in the question is 0.2. So times 0.2. Okay, so we are going to have 10 minus 10 times 10 is 100. So 100 mu equal to 0.2 times 10 will give us 2. So we are going to have 10 minus 2 is equal to 100 mu, collecting like terms. 10 minus 2 is 8, equal to 100 mu. So from here you can see that your mu here is equal to 8 over 10, which will give us 0.08 as the answer. This is beautiful. So the answer to this question is B. Okay, so let's look at another one. It says a 100 kilogram box is pushed along a road with a force of 500 newtons. That's the applied force. If the box moves with a uniform velocity means it is not accelerating. When an object is moving with uniform velocity, it means that that object is not accelerating. The coefficient of friction between the box and the road is, actually the proper formula is F minus this equal to ma. But because it is not accelerating, it means that F minus F is equal to 0. Acceleration is 0. And we can just say F is equal to frictional force. Beautiful. So my force, our applied force is 500. My frictional force, like we know, is mu mg. So 500 now is equal to mu is what I'm looking for. The mass in the question is 100 kilogram. Acceleration due to gravity is 10. So that means mu now will be 500 divided by 100 times 10 is 1000. So that's going to give us 0.5. So my coefficient of friction is 0.5. Beautiful. Now look at another question here. It says a load is pulled at a uniform speed along a horizontal floor by a rope at 45 degrees to the floor. So this force is acting at an angle. If the force of the rope is 1500 newtons, what is the frictional force on the load? Okay, read the question again. A load is pulled at a uniform speed. See the word uniform speed, meaning it is not accelerating. And whenever it is not accelerating, F is equal to F. So from here you can see that an object is not accelerating if, number one, it is about to move, it is not accelerating. Then secondly, if it is moving with a uniform speed, and in that case the frictional force will be equal to the applied force. Now, but in this case now, my applied force is F cos 45 because the force is acting at an angle, which I believe you can watch my video on resolution of forces. So F cos 45 equal to, this is mu mg. Okay, we are asked to find the frictional force, so no need, so just F. Now what is F here? 1500 cos 45 is equal to my frictional force. So if I use my calculator to find 15 times cos 45, it's giving me 1060.66. 1060.66, okay, which is of course approximately 1061 newtons. Beautiful. Now let's look at inclined plane. Okay, so you see this diagram of an inclined plane. First of all, we are going to consider smooth surface before we see rough surface where friction is applied. Now on a smooth surface, you can see the forces acting on an object on an inclined plane. First of all, you see that the weight is acting downwards. That's mg. This is mg acting downwards. Now, but this downward weight has a component. Okay, it has a horizontal component which is mg sin theta and has a vertical component which is mg cos theta. Now the horizontal component, which is the mg sine theta of that weight, is the force that pulls any object down an inclined plane. An object down an inclined plane is pulled by the force mg sine theta. Okay, then why mg cos theta is the normal reaction. If you notice, r here is mg cos theta. They are equal and opposite. Okay, so we should know that. So the normal reaction of an inclined plane is mg cos theta, but the force that pushes any object down an inclined plane is mg sine theta. Now, as we see here, mg sine theta is equal to ma here. Why? According to Newton's second law, the resultant force acting on a body must be equal to the product of its mass and its acceleration. So here the resultant force is mg sine theta, okay, equal to the product of mass times acceleration, ma. So if m cancels m, mass cancels mass, you are going to be left with a equal to g sine theta. So when an object is sliding down a smooth inclined plane, the acceleration of that object, a, is equal to g sine theta. Please note that. On a smooth inclined plane. Okay, so now that leads us to a rough inclined plane. When the surface is rough, now you notice here, so you can see that there is a frictional force that is opposing the motion. This is acting downward. Frictional force always opposes motion. It's always in the opposite direction of motion. So that is what we have. So please note that. Now we are supposed to have two cases. The first one is the static. Now remember, if it is static, the applied force must be equal to the frictional force. Okay, so you see that the frictional force is mg sine theta. The frictional force is equal to the applied force, which is mg sine theta. Now, and the frictional force is mu r, so mu r equal to mg, okay, sine theta. Then we have that, what is r? If you substitute r is mg cos theta. So we have mu mg cos theta is equal to mg sine theta. Now, if they cancel out, okay, you see that if m cancel out, because m is common on both sides, both m and g, we're going to have that mu cos theta is equal to sine theta. Now, if I want to make mu the solid of formula, mu will be equal to sine theta over cos theta, like we just saw now, which is tan theta. So you should note that the coefficient of static friction is equal to tan theta. That's a standard. Coefficient of static friction is equal to tan theta. Now let's see for dynamic friction. If it is a dynamic friction, the applied force minus, actually it is supposed to be the other way around. That means mg sine theta minus ma. Okay, so that's actually a mistake. So please note that it should be the other way around. So here my frictional force is mu mg cos theta minus mg sine theta equal to ma. So if I divide through, mass is common through, I'll divide through by m. I'm going to have mu g cos theta minus g sine theta equal to a. And okay, let me say something here. So based on the correction I just made, we can say that a is equal to actually g sine theta minus mu g cos theta. Okay, please, that's a correction. So we move to questions. Here it says an object of mass 20 kilograms slides down an inclined plane, inclined at an angle of 30 degrees to the horizontal. The coefficient of static friction is, from what I've shown you, coefficient of static friction is simply equal to tan theta. So the theta here is 30 degrees, so that means tan 30. So if we are to, with our calculator, to find tan 30, we are going to get 0.577, which is actually 0.6. So D here is the answer. Okay, we see another question here. It says a 5 kilogram block is released from rest on a smooth inclined plane. This is smooth now. Inclined at an angle of 30 degrees to the horizontal. what is the acceleration down the plane? Since the surface is smooth, the acceleration down the plane A is simply g sine theta, as simple as that, g sine theta. Okay, so in this case here, my g, acceleration due to gravity, is 10, then sine theta, theta is 30 degrees. So 10 sine 30 with your calculator is going to give us 5.0 meter per second square. So A is the answer also for this. Now let's see another question here. A 5 kilogram block is released from rest on a rough plane. A rough plane is rough, inclined at an angle of 30 degrees with the horizontal. What is the acceleration down the plane? So this is not static, it is moving. So the acceleration down the plane from what we saw is g sine theta minus mu g cos theta. Okay, that's quite easy. So your g is 10, so 10 sine 30 minus mu g, your mu is 0.3 times g, which is 10, then cos 30. So let's use our calculator to know what that will be. So we have 10 sine 30, then minus 0.3 times 10 cos 30. So we are going to get 2.4. The answer is 2.4 meter per second square. Okay, we don't have any 2.4 here. But 2.4 is the answer. I guess there was a mistake somewhere, but 2.4 meter per second square. The answer is not in the option. Okay. Now this leads us to systems of forces. Now look at this system of a table, two masses, M2 and M1, but M2 is greater than M1, meaning that the total force will always move downward this way. So when you have a system of force like this, sometimes you may be asked to calculate, the acceleration of the motion, especially either when the surface is smooth or when the surface is rough. Now let's see what happens when the surface is smooth, for smooth surface. So you see that for the M2, that's for the mass M2, M2G, which acts downward, minus T equal to M2A. According to Newton's third law of motion, the resultant force must be equal to mass times acceleration. So since it's moving downward, it means that M2G, the weight, is greater than the tension. So when you subtract it, it is M2A. Okay, but for M1, the only force acting on M1 is the tension there, which is dragging it. So, and the resultant force is that tension, which is mass times the acceleration. So we have for M2 and for M1. Now, if I combine the two equations together, both equation 1 and equation 2, we are going to have M2G. We do that by adding. Just add left-hand side to left-hand side, right-hand side to right-hand side. Okay. We have that M2G minus M1A equal to M2A. Another way you can say it is that in equation 2, in equation 1, just substitute the value for T. Since T is M1A, so we have this M1A equal to that. Okay, so let's proceed. Now you see that M2G is equal to, if M1A moves to the other side of the equation, we have M1A plus M2A. And when you factorize your acceleration, make acceleration subject of formula, you can see that the acceleration will be M2G over M1 plus M2. M2G over M1 plus. Do well to remember that formula. Now let's see if the surface was rough. For M2, will still remain the same, M2G minus T, because there is no frictional force there, equal to M2A. But for M1, there will now be a frictional force here, acting this way, opposing the motion, F. So the resultant force, it will be T, the tension, minus mu M1G, okay, that's mu R, right, equal to M1A. Now, if I add the two equations together, I'm going to get M2G minus mu M1G. Adding the two equations together will cancel this, minus T plus T is 0. So I'm left with just mu 2G minus mu M1G equal to the right hand side, m2a plus m1a. Okay, we can factorize. G is common on the left hand side, a is common on the right hand side. So by the time we are done factorizing, what do we have? Acceleration now will be m2 minus mu m1 all multiplied by g all over m2 plus m1. Remember that m2 is always greater than m1. Okay, so let's see just a question here. It says in the figure above, you should notice that there's a rough surface, smooth pulley. Okay, the figure above, the coefficient of static friction is 0.5. If the tension in the string is T, the acceleration of the system in the motion is, how do we find the acceleration? I've given you a formula for that. Your A here is equal to m2 minus mu m1 all over m2 plus m1. But remember, the numerator is multiplied by g. So let's apply that. So this will be equal to, your m2 is 6 minus mu m1, that means 0.5 times 3. Then g, as we know, the gravity is 10. So all over m2 plus m1, that means 6 plus 3. So that will be 6 minus 1.5, that will be 4.5. All over, this is 9 times 10. Okay, the answer is 5. So 5 meters per second squared is the answer to this question. Okay, so this comes to the end of the topic friction. I believe you understand the topic. Have a nice day.